Welcome to Cosmic Compass, the channel where we journey across the universe to uncover the secrets of space astronomy and the worlds beyond Earth. Every planet, every moon, every star tells a story, and together we'll piece them into a bigger picture of our cosmic home. Today, let's turn our attention to one of Jupiter's moons. You've probably heard of Europa, Io, or Ganymede, but what about the one that seems to sit quietly in the background, almost forgotten? This is Callisto, an ancient world, scarred and silent, yet holding clues that could shape our future in the solar system. When we talk about the Galilean moons of Jupiter, names like Europa or Io often come to mind, worlds that dominate the spotlight with stories of erupting volcanoes and vast oceans hidden beneath ice. But among these giants lies one of the most ancient, unchanging landscapes in the entire solar system, Callisto. It is nearly as large as Mercury, older than any surface we've walked upon, and yet how many facts can you recall about it? Perhaps very few. Today, let's journey to Callisto, a moon that has quietly preserved the scars of billions of years, and uncover why this forgotten world may one day become a stepping stone for humanity among the stars. Callisto is the third largest moon in our solar system, with a diameter of about 4,120 kilometers, just slightly smaller than Mercury. Yet, despite this size, its mass is only about 1/3 of Mercury's, showing us that it is far less dense, composed largely of ice and rock rather than heavy metals. Orbiting Jupiter at nearly 9 million kilometers away, Callisto circles its parent planet once every 17 Earth days. Even at this distance, it remains tidally locked, always showing the same face to Jupiter. But unlike its siblings Io, Europa, and Ganymede, Callisto is not trapped in an orbital resonance. This separation makes it a loner, untouched by the constant gravitational tug-of-war that stirs activity on the other moons. Callisto carries a whisper of an atmosphere made mostly of carbon dioxide, with a hint that oxygen might be present, though no direct evidence has yet been found. The layer is so thin that molecules almost never collide with one another. Theoretically, this atmosphere should vanish within just a few years, but scientists believe it is constantly replenished by the slow sublimation of icy deposits across the surface. And what a surface it is! Callisto's crust is among the oldest we've ever seen, more than 4 billion years in age. Unlike Earth with its mountains and oceans, or even Europa with its shifting ice, Callisto's face is frozen in time. Its landscape is saturated with impact craters, so much so that new impacts often overlap older ones. This is a world where almost nothing has changed since the solar system's earliest days. Why does Callisto appear so ancient, while its neighbouring moons seem younger and more dynamic? On Earth, erosion, tectonic activity, and even life itself erase the evidence of impacts. On Io, volcanoes constantly resurface the land. Europa's ice shifts and cracks under the stress of tidal heating, while Ganymede experiences its own tectonic processes thanks to gravitational resonance. But Callisto stands apart. Isolated from resonance, it avoids tidal heating almost entirely. Without heat, there are no volcanoes, no tectonic plates, no resurfacing forces at play. This means that Callisto remains geologically silent, preserving a record of every asteroid and comet that has ever collided with it. Among Callisto's most striking features are its immense craters. Asgard, for example, stretches over 1,600 kilometers wide, while Valhalla is even larger, 800 kilometers in diameter, making it the biggest multi-ring impact structure in the solar system. These impacts were so powerful that they may have punctured Callisto's crust entirely, leaving behind lighter-coloured central regions where ice refroze after the chaos. Look closely and you'll notice bright knobs scattered within these rings, remnants of countless degraded craters, weathered down by micrometeor impacts or by slow sublimation of ice over time. They gleam brighter than the darker plains, where rocky debris has settled, and buried older ice. Not all craters follow the usual rules. Some are unusually shallow, like the Loffen impact, which spans over 100 kilometers across but is less than a kilometer deep. Others, like Tinder, reveal pits instead of central peaks. These anomalies suggest that beneath Callisto's brittle crust lies either soft ice or perhaps a thin ocean, making the moon's surface more complex than it first appears. Data from NASA's Galileo probe revealed something surprising. Jupiter's magnetic field does not fully penetrate Callisto, implying a conductive layer beneath its surface. The most likely explanation is an ocean of salty liquid water hidden perhaps 100 kilometers below the crust. At the center, Callisto holds only a small silicate core, unlike the more differentiated worlds nearby. This raises the question, could Callisto harbor the conditions for life? After all, liquid water is one of the key ingredients. But here the challenges become clear. At nearly 800 million kilometers from the Sun, Callisto receives little warmth. Without tidal heating, the only internal energy source would be radioactive decay in its rocks. And unlike Europa or Enceladus, which spray plumes of water into space, Callisto shows no signs of vents that could give us direct access to what lies beneath. For now, the mystery remains buried deep and out of reach. While Callisto may be less promising for alien life, it could hold great promise for us. Its orbit lies beyond Jupiter's intense radiation belts, making it thousands of times safer for human explorers than Europa or Io. Add to this an abundance of water ice, and suddenly Callisto becomes an ideal candidate for a human outpost. From this ice, we could extract not just water for survival, but hydrogen and oxygen for rocket fuel. Its low gravity would make launches easier, while its geological stability would offer a solid foundation for permanent structures. Imagine a research base on Callisto where astronauts gaze upon Jupiter's swirling clouds from a safe distance, using this moon as a gateway to explore the outer solar system. For now, our knowledge of Callisto is still limited. The Galileo spacecraft gave us tantalizing glimpses, but much remains unexplored. The European Space Agency's JWST mission, set to study Jupiter's system in the coming decade, will perform several flybys of Callisto. These encounters may finally reveal whether an ocean lies beneath its crust, and if so, how stable it has been over billions of years. But beyond the questions we already have, new mysteries are bound to emerge. What secrets might be locked inside this ancient world, waiting to be uncovered? Callisto may not boast fiery volcanoes like Io or promise alien oceans like Europa. Instead, it offers us something else, a perfectly preserved relic of the solar system's past, and perhaps a key to our future in space exploration. It is a world of silence, yet it speaks volumes about the history of planetary formation, and one day it may be the place where humanity plants its first long-term outpost beyond Mars. So as we look deeper into Jupiter's system, let's not forget Callisto, the quiet witness of time, a frozen world that might one day guide us further into the cosmos. If you enjoyed this journey to Callisto, there's so much more waiting for us out there. From fiery volcanic moons to icy planets on the edge of the sun's reach, every world has a story to tell, and we'll be here to explore them together. Make sure to subscribe to Cosmic Compass so you don't miss our next voyage into the mysteries of space. And if you'd like to support this channel, you can check the links below. Your help keeps us exploring the cosmos. Until next time, keep looking up, and remember, the universe is vast, but together we can navigate it.